Welcome, Course 2 to the Kaloran Show. Today we are talking about Lesson 83, multiplying numbers in scientific notation. It is my take 2, so I should be a professional at this lesson again by the end of the day. So we're going to start out by talking about things that you know about multiplying numbers in scientific notation. I know that you will pause this video and write those down at this moment in time, so go ahead and do that. Oh, you tricked me. I'm sure that you got all these things written down, but the first one that's very important is when multiplying numbers with the same base, we can add their exponents. That is one rule of multiplication and same base numbers. So very important for scientific notation. The other very important thing is when we leave a number in scientific notation, we must have only one natural number to the left of the decimal point. With that being said, I mean, make sure we're writing down these important things, but here's the biggest part of these two statements is the same base. When multiplying, add the exponents. Okay, down here, when we leave a number in scientific notation, okay, so scientific notation, we must only have one natural number left of the decimal. Okay, very important keys there, so don't forget those. The other things that you may not have written down, if you chose to write down along with me, is the commutative property, and down here you'll see as soon as I scroll down the associative property. Today the biggest commutative property we're going to talk about is in multiplication. So commutative property says that 2 times 4 is the same as 4 times 2. We can change the order of our numbers, and showing this proves that it is true. Down here, the associative property. The associative property says that our grouping can change. So the order that we group in, so 2 times 4, and let's go 3 times 2. Okay, so this is multiplication. If we group these numbers, 2 times 4 is 8, and 3 times 2 is 6, and those two multiplied by each other is 48. If I wanted to change the order, 2 times 3, so I use the commutative property, and I'm going to group these numbers, 4 times 2. That's also the associative property, telling me I'm going to multiply 2 times 3 first. 2 times 3 is 6, 4 times 2 is 8. So there you see the commutative property and the associative property, and they both get you the same answer. So they do work, and we're going to be using them today, especially in this step right here. So your first problem says to multiply these two scientific notation numbers. So what we're going to do first is we are going to change the order. Okay, so that our rational numbers are together and our base numbers are together. Okay, we are also going to implement, so we used commutative property. Okay, and then I'm going to use red to show you the associative property. Okay, and the associative property is going to be done like so. So that's going to show you we're going to multiply the numbers on the left, and we're going to multiply the numbers on the right, and then we're going to combine them. Okay, so first one, 1.2 times 3. Okay, if we're struggling on math, we can show our work. 3 times 2 is 6. 3 times 1 is 3. Remember, there is one decimal place, so move your decimal over 1. So 1.2 times 3 is actually 3.6. Our multiplication is just carried down. Now here, we do have the same base numbers. If we have the same base numbers and they are being multiplied, we can take these exponents and we can add them. So our base is still going to remain the same. We're going to have that base 10, except for our new exponent is 5 plus 7. Okay, so our scientific notation number is 3.6 times 10 to the 12th. Okay, and the steps we took there were multiply. That's what we did in that step. In step 4, we simplified. Okay, added those exponents. So again, we saw some addition property of equality. Here's your answer. We have to ask ourselves, is this in scientific notation? Is there one natural number to the left of the decimal? Yes. That means done. Move on. Okay, next problem we're going to work through. We are going to reorder the numbers. 4 times 3 times 10 to the 6th power times 10 to the 5th power. Notice that we reordered the numbers so that we could have our same base numbers together, and we could have these together. Don't forget that in between here, if there is no symbol, that means multiplication. Okay, so which properties did we use there? We used the commutative or commutative, however you pronunciate, and the associative. Okay, both properties were utilized in that step. So now we need to multiply. 4 times 3 is 12. Okay, same base. So we're going to have a multiplication down here. 10 is your base, so we're going to take that base down. Then we're going to look at our exponents. And if we are multiplying same base numbers, we can add our exponents. 6 plus 5 is 11. Ask yourself, is this number in scientific notation? No. Okay, no it is not. So, first I'm going to write down that we multiplied over here. This is giving us reason for what we're doing. So we multiplied, and now we need to convert it. So if we are going to turn this number into proper scientific notation, we have to take our decimal number, which is obviously behind the number if it's not there, okay? So there's our decimal point. We need to move it over. So we're going to be moving our decimal point over to the left right here, okay? Because we only want one natural number. So there's our natural number. One natural number to the left of the decimal. When we move that over, you can't just move it over and keep your 10 to the 11th power. Because we moved it over, we have to do something to this exponent, okay? Here we have 1.2, and if we move it to the left, if our number got smaller, which it did, that means our exponent has to increase by the number of times the decimal moved. So our decimal moved once, so that means our exponent is going to increase one time. So 1.2 times 10 to the 12th power. Okay, proper scientific notation. Okay, we had to get one natural number to the left of the decimal. And I'll show you how that works too. If we had 12 times 10 to the 11th, here is 12, we would have 11 zeros. 5, 6, 7, 8, 9, 10, 11. If there were 11 zeros, in order to get into scientific notation, we are going to want 1.2 because that's where we want our decimal to go. How many times do we have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there you can see that the number in standard form gets you to 1.2 times 10 to the 12th, which is simplified scientific notation. All right, next problem, we have negative exponents. Ooh, scary. Still change your order. 2 times 3 times 10 to the negative 5th times 10 to the negative 7th, so you can get your scientific notation numbers together. We're going to follow the same steps, so I'm used commutative property. Now I'm going to show you your associative. We're going to multiply 2 times 3, which is 6. Now we can see that these are the same base and they're being multiplied. So we're going to take our exponents and we are going to add them. Okay, another rule you're going to see here is addition of numbers. Okay, so when we add two numbers and they are the same sign, so when we are adding same sign numbers, we are going to add and then we are going to take sign of both. Very important rules and we often forget them. Okay, the other difference is when we add and they are different signs. What happens? Scary things, that's what happens. If they are different signs when we're adding, we have to remember to subtract and then subtract the positive numbers. So subtract the absolute value of each number. Okay, make sure you don't forget that it's the absolute value of the number. Subtract the absolute values of each of the numbers and take the sign of the larger absolute value. Okay, so we want to take the sign of that larger absolute value there. So here we're adding same sign. So we are going to put our multiplication down here. We're going to put our same base And when we add the same sign, we have -5 and -7. The same sign, so we're going to add them. 5 plus 7 is 12, and we're going to take the sign of both of them. Do we have proper scientific notation? Yes, we do, because there is only one number to the left of our decimal, one natural number. Moving on, we're almost done. This is our last one and the most complex one of all. Commutative property says, cha-ching! Change the order. You got it right. I know you're saying it in your head because I can hear you. And associative property says, regroup that baby, Mrs. Kaloran. And that's just what I did. 5 times 7 is 35. Our multiplication comes down. Here is a 10. The most complex part of this. I carried the 10 because they are the same base. They are being multiplied. So now we need to take this exponent and this exponent, and we need to add them. That is our rule. So when we add them, what do we get? Well, use the rule from the last page, you're thinking. I was thinking the same thing. The rule from the last page said that if we had different signs, we were to subtract, okay, the absolute value. So 8 minus 3, okay, absolute value is just the number. 8 minus 3 is 5. And then you were to take the sign of the larger number, which puts us at a -5. So what is our exponent? 3 plus a -8 gives you a -5. Proper scientific notation? No. Fix it. Biggest pet peeves and actually the most errors in scientific notation is to not finish the job, okay? So we've got to make sure that we make our number smaller here. Okay, and if we make our number smaller, we are going to be increasing the exponent. Your scientific notation with one natural number to the left of our decimal is 3.5. Our base stays the same. The only thing that changes is here. Here we are again adding. Okay, and we're adding different sign numbers. So that means we are going to take the absolute values and we are going to subtract. 5 minus 1 is 4. And then we're going to take the sign of the larger number, which is a negative. So your new exponent, -4. So your solution for this scientific notation problem is 3.5 times 10 to the -4. Final answer. And we made it through today's lesson. If you forgot your textbook, I have put the practice problems right up here. Complete these right away and make sure you have the correct answers. You can check them by writing the numbers out in standard form. But your solutions should be in scientific notation. Thank you for joining me today and have an excellent day.